We were just working on the X-Intercept on the bottom of page 9 on 7.2. We had just found x equals 7, and it was a double root. And so that means there's only one X-intercept, and that would be x is 7, y is 0. So that is your answer for part B. And then I went ahead and did part C because it's super easy. So y-intercept means make x 0. So I went up to the equation, y equals 0 squared minus 14 times 0 plus 49. 0 minus 0 plus 49 is 49. So that means the y-intercept is 0, 49. So if you look over here on your picture, it'll be way up at 49 when it crosses the y-axis. So one more to do on the next page, and then we're going to review what we've learned so far this chapter. So if you want to go ahead and shut the video off and do number 11, that would be really good practice for you for the test. And then when you come back, we'll do it together. So this parabola, because there's a negative, cups down. So I'm going to draw a little picture here just to remind myself of that. We'll draw a little axis here. So we know it crosses, it cups down, but we don't know if it cups down here, cups down up here. So let's go ahead and see. So once again, they want us to do the discriminant to determine how many x-intercepts it has. So if it has 2 x-intercepts, then its vertex is going to be somewhere up here. If it has no x-intercepts, that means the graph's going to be somewhere down here because it won't cross the x-axis. So let's check and see. So A is -1, B is -2, and C is -5. So we want to find out what b squared minus 4ac is equal to. So b squared, -2 times -2 is +4 minus 4 times a, which is -1, times c, which is -5. So b squared, -2 times -2, +4 minus 4 times a times c. So then we plug it into the calculator. 4 minus 4 times -1 times -5. So you can either use a times sign or parentheses, it doesn't matter. And we get -16. So b squared minus 4ac equals -16. That means we have this scenario. So what kind of numbers do you get from that? Imaginary, right, because of the negative. So that's 2 imaginary solutions. Now we got to think what that means on the graph. Can I find 2 imaginary numbers up here on the x-axis? No, this is the real number line. It does not contain any imaginary solutions. So what that tells me is there's no x-intercepts. So determine if there are any x-intercepts. Imaginary numbers aren't on the x-axis. That's why we go and say no x-intercepts. So we know now that the graph is going to be somewhere down here because it cups downward and it doesn't ever cross the x-axis, because if it was up here, then it would cross the x-axis twice. So it's going to be somewhere cupping down there. So find the x-intercepts if they exist. They don't. You could just say do not exist. So now we just have to find the y-intercept. So y-intercept, remember, means make x 0. So we go up here and we say, okay, this is our y, so we're going to make x 0. So y equals -0 squared minus 2 times 0 minus 5. So 0 minus 5 is negative 5. So that would make my y-intercept. X is 0, y is negative 5. So now we have a better picture of the graph. It's going to go through the y-axis at negative 5. So it's either going to look like this or it's going to look like this. We'll just make a guess. So it's going to look something like that, or possibly over there. We don't know until we learn how to find the vertex, which is coming up in a couple sections. Okay, so it cups down because of the negative leading coefficient. It never crosses the x-axis because it had imaginary solutions, but it does cross through y at 0, negative 5. So it could be over there and cross through y, or over here. Okay, so let's summarize what we've learned throughout this section and the first section. This is a heavy-duty chapter, so it's kind of nice to keep going back and reviewing. I don't know what that is. So the first thing we learned, this actually came from chapter 4. So before we came to chapter 7, we only knew one way to solve quadratics, and that was factoring. Factors of 5 that subtract a 4 are 5 and 1. Largest one's negative, so x minus 5, x plus 1. Then we set each one equal to 0. So x equals 5. Set this one equal to 0. X equals negative 1. And then because it has two solutions, we write them in solution sets, negative 1 and 5. And remember, with every quadratic, we know there's always going to be two solutions. Sometimes they'll be the same number twice, but there'll always be two solutions. Next, we learned the square root property. That was in 7.1. And that's when we have a squared value and a constant that we know to use it. So for square root property, we had to isolate the square. And remember, you have to know these by name on the test. If you look at your practice test, I ask you by name. So square root property. So that means isolate the square. Completing the square. That's where you make a perfect square trinomial and add the same number to both sides. Quadratic formula. That's where you use x equals the opposite of b plus or minus. Factoring. That's where you use the method we just did up here. And then these two you get a pick. But I can see they're both a squared quantity and a number, so for both of these you're going to move the constant over to the other side and do the square root of both sides. So those will both be square root property. So you do have to know them by name. So when it says use the square root property, we isolate the squared value, move the other thing over, so subtract 16 from both sides. And then once we get our squared isolated, remember we square root both sides and we add a plus or minus. So anytime you square root both sides of an equation, you must add a plus or minus. So plus or minus the square root of negative 16 is plus or minus 4i. From the last chapter, we learned that any negative under a square root comes out as I. So those two solutions would be negative 4i and positive 4i. And every one of these, by the way, is on your test. So this would be a good box to highlight. So there are the first 6 problems come from this box right here. Actually 7, because the one on the top of the second page is also a factoring problem. So this is 7 test questions right here. It's number 1 through 7 on the test. Okay, the next method we learned was completing the square. This is definitely the hardest thing we learned in this chapter. We did quite a few of them though in the last, or at the beginning, in 7.1 in the last section. So When we're completing the square, remember we have to bring the 7 over. And then we do half of b squared. So that was the first formula we learned, and that's to make a perfect square trinomial. That's why it's called completing the square. So b is -4. Quantity squared, so half of -4. Excuse me. Half of -4 is -2. Squared is 4. And that's why we added 4 to both sides. So that 7 moved over because we need x's on the left, constants on the right when we're completing the square. Then we did half of b squared, and that's where we got this number. Then we learned how to factor this a short little way. Hopefully you remember that. That's where you take the square root of the first term, use this term, and the square root of the last term. So remember, that's only for completing the square do we use that. So square root of x squared is x. Bring down the minus. Square root of 4 is 2. And it's going to be x minus 2, which is x minus 2 squared. 7 plus 4 is 11. And now it's just a square root property. Squared quantity equal number, square root both sides, add your plus or minus, and then you add your 2 over. And remember, when they're not like terms, you just tuck that 2 right in front of the plus or minus. So my two solutions are 2 plus or minus 11. So we would write it as 2 plus rad 11 and 2 minus rad 11. And all your answers on your test should be written in solution brackets, just like we've done on our homework and in our notes. So there's the first set, second set, third set. And then the last one we learned was quadratic formula. So now anytime you're asked to solve a quadratic, which means second degree equation, this is kind of the steps. First you see if it can factor. Then if it just has a squared quantity and a number, you can use square root property. And generally, unless you're asked, students will skip to quadratic. They won't do this because this is definitely the harder of the 4. So if factoring doesn't work, then this is my plan B, quadratic. So now we can solve every single quadratic in the world knowing these 4 things. So first try factoring. If it doesn't work, then jump into quadratic formula, unless you have a squared quantity and a number. And this is valuable. We need to learn it in this class because it will help us find the vertex later of the parabola. And also remember, I said it's in 150, you find it to use the center of a circle, center of an ellipse. You use this a lot, vertex of a parabola. So it's important that you know it, but we just don't use it that much unless we're working with conics. Okay, so let's try these out. It doesn't look like we're going to get through all 3, so we'll have one little shortsy video at the end to finish this section. So solve the equation. So immediately I see a squared quantity and I see a number. So right away that tells me use the square root property. So we use the one that's quickest, and that's the one that's quickest. I mean, yes, you could FOIL that and blah, blah, blah. That'd be a mess. Much easier. Square root property, you just square root, because see how the squared quantity is isolated? Square root. 2 of anything pops out as 1. So we have 3x plus 8 equals, because we square rooted both sides, plus or minus. You miss 8 problems if you forget that on your test. Plus or minus every time you square root both sides. And then we learned on this how to do 2 scenarios. So our first scenario that'll give us our first answer is 3x plus 8 equals positive 6. Our second scenario is 3x plus 8 equals negative 6. Solve those 2 and you'll have your 2 solutions. So subtract 8, 3x equals negative 2, so x is negative 2/3. That'll be my first solution. And then my second solution comes from this, negative 8, 3x equals negative 14, so x is negative 14 thirds.